Which function is the same as 3x to the third minus 5x squared minus 5x minus 1? Okay, so we don't have to check every single one if we remember, guys, that the last term times the last term needs to make -1, right? So -1 times -1 makes +1. So it's not A and it's not C, but it could be B or it could be D, so we're going to have to work those out. All right, so I've written down B, guys. Going to multiply it out, so that's 3x to the third plus 3x squared minus 2x squared minus 2x minus x minus 1. All right, that doesn't combine with anything. That makes 1x squared minus 3x minus 1. All right, so that is not the correct answer, so that means it must be D. So real quick, guys, I'm going to multiply this one out as well. That's 3x to the third plus x squared minus 6x squared minus 2x minus 3x minus 1. That does not combine. Those combine and make 5x squared minus 5x minus 1. And there you have it. So D is the correct answer on that one. Alright, next question, guys. Which function has a 0 with a multiplicity of 3? Alright, pretty easy, guys. Definitely not that one. This one has x minus 5 twice. This one has x minus 2 twice and x plus 2, but that's not the same. And this one, of course, has x minus 1 to the third, so that is multiplicity 3, right? That simple. It has that 0 3 times. And next question. Determine the product of 2 plus 4i times 2 minus 4i. Alright, so that is 4 minus 8i plus 8i minus 16i squared. That becomes -1, and that just changes that to a plus. Alright, and then these two cancel out. 4 plus 16 is 20. That's it. Alright. So we did a bunch like those, so hopefully that one was pretty straightforward. Alright, and then one of these long ones here, analyze the function, select all which are true statements. So definitely most people missed at least part of this question. The function has exactly one imaginary solution. Impossible. Right? You have to have at least 2 or 4 or 6 and so on. Imaginaries always come in pairs. Alright, but we definitely have some imaginary solutions, right? Because we have these extra curves, these extra bends. So that means we have imaginary solutions. Alright? So the function does have at least 2. But remember, guys, imaginaries always come in pairs. You can't have 1. The function has the factor x minus 2. So guys, remember, x minus 2 would correspond to a 0 of positive 2, right? Since 2 minus 2 would be 0. So no, we don't go through positive 2, so that is no. The function has x plus 2, though, because that corresponds to -2, and that is a solution, right? That's a 0 because it does hit there with a multiplicity of 2 since it bounces. So it has that factor twice, in fact. There is a real root which has an odd multiplicity. Yes, because it crosses right here. And there is a real root with an even multiplicity. Also yes, because it bounces on -2. So that's an even multiplicity root. And then f of x is less than or equal to 0 on the interval from -2 to 1. So that is from -2 here to +1 here. Is f of x less than or equal to 0? That just means below the x-axis. And yes, it is. So between -2 and 1, our function is below the x-axis. So that is true. The function is increasing on the interval from 0 to 1. From 0 to 1. We go down first, and then we go up. So no, that is not true. Using x equals 0 input results in an output of 4. So that's saying that the y-intercept at 0 is -4, or positive 4, never mind. So definitely not true either way, right? Because the y-intercept is -2. And then finally, using x equals -1 as an input results in an output of 0. So it is -1 right here, an output of 0, a solution? No, because it does not touch the x-axis there. So that is not true either. So guys, these are really important questions, all right? So make sure you understand why these three were not true, why this was not true, why this was not true, and why these five were indeed correct, all right? That is important. All right, next question, guys. Write an equation for the following function in the form y equals. All right, so there's an important one that we did a bunch. So we have one solution right here that bounces, and we have one solution right here that crosses, and we have our y-intercept right here. All right, guys, so since it bounces at -2, that corresponds to x plus 2, right? That's our factor. And it bounces, so that means we're going to square it. Since it crosses at positive 3, that's going to be x minus 3, right? So that's -2 bouncing, and that's positive 3 crossing. And then we put an a in front, all right, and that's our function. And we solve for a by inputting 0 for x. So 0 plus 2 is 2. Still keep the square. 0 minus 3 is -3. Right? If I input 0 for x, I should output the y-intercept 6. Right? 0 for x, y-intercept is 6. All right, so then we have a times 4 times -3 is -12. Divide both sides by -12. A equals -1/2. All right, so all that we got to do is replace that a right there with -1/2 and type all that in. All right, so -1/2. And this is in the way there. -1/2. It just gets in the way. And then, there we go, x plus 2 squared and x minus 3. Right? So again, guys, that's x plus 2 squared because of that solution, and x minus 3 squared, x minus 3 not squared, just regular because of that solution where it crosses. And we solved for our coefficient in front, -1/2, by using that y-intercept right there. All right, analyze the function graph. So we have what kind of thing here, even or odd? Even, since it's matching end behavior. Leading coefficient is positive since it's going up, right? Both ends go up. How many relative minimums does it have? Well, it's got one dip there, one dip there. That is 2. Where did I just go? No, I don't need their help, do I? Let's go back. There we go. All right, 2 minimums. Boom. On what intervals is the function less than or equal to 0, right? So that's asking, guys, where is it below the x-axis? So basically all the way from here, -3 to +2, right? Because this is all below the x-axis, all of this. So the function is less than or equal to 0 below the x-axis from -3 to +2. Go. All right, plot the complex number. So a lot of people forgot how to do this, even though it's very easy, guys. That's just our x-coordinate, and that is our y-coordinate. That's it. -2, +3. -2 on the real axis, +3 on the imaginary axis, y, or the y-axis. That's it. -2, +3. Super easy. Just got to remember how to do it. All right, write the result of dividing 2x² minus 4x² minus 19x plus 12 divided by x minus 4. All right, so that's going to be using that synthetic division we learned. All right, guys, so I've rewritten the problem here. Set up our synthetic division. 4 goes here. Draw your line. And we have 2, -4, -19, +12. That comes down, right? You can put a little plus there, a little times there. So 2, 8, 4, 16, -3, -12. You should get 0, of course. Well, I shouldn't say you should always get 0, right? But that means that this is a factor of this, right? And that 4 is a solution, since we get 0 remainder. All right, and if we started with x to the third, we now have 2x squared plus 4x minus 3. All right, let's just type that in. 2x squared plus 4x minus 3, of course. And the next one, guys. Super important one, right? Very, very important one. A lot of people miss this one, though. So start by using the calculator, then divide, then ... Okay. So, guys, start by using the calculator, what I mean is that the way you start to solve something like this is you type it into y equals and you graph it. All right? You type this into y equals and you graph it. All right, guys, so I don't have a graphing calculator here, but it works just the same, right? So if you type it into y equals, you hit graph, you'll see something like this. So what does that tell us, guys? That tells us that -3 is a solution, right? -3 is a solution, or x plus 3 is a factor. All right, guys, so again, once you type it in, you see it does something like this, right? Crosses at -3. What that means, y'all, is that -3 is a solution given to us by our graphing calculator. X plus 3 is a factor. And then we can use that to divide out that factor, right? So we do our good old division here, synthetic division. A little plus there, a little times there. 1 plus nothing is 1. -3. -4, positive 12. 5, -15, and 0. All right, we started with x to the third. So now I'm at 1x squared minus 4x plus 5. Right, so that I can finish solving. I could try to factor it, but it does not factor, so that's why we do the quadratic formula to get the remaining solutions. All right, so -b. All right, just clean up from here. All three of these are divisible by 2. And those are our two solutions, right? So also don't forget to include -3, the one we got from our graphing calculator. All right, so -3, so 2 plus I, 2 minus I, and -3. 3 solutions, right? Which is what we wanted because it is a cubic, right? So very important question, guys. We'll use our graphing calculator to get the real solution right there, the real solution. All right, that leaves us with a quadratic formula, quadratic that we can use the quadratic formula on to get our two imaginary solutions. All right, guys, so let's take a look here. So this is my number 1. So which type of polynomial could a graph with the given shape represent? Well, first of all, guys, the two ends are going the same way. So that means we know it is even. So that means it could not be 3rd or 5th degree. And then we have 1, 2, 3 bends, right? Which means it couldn't be 2nd degree. It has to be at least 4th degree or higher because of the 1, 2, 3 bends in the graph. All right, so for that one was pretty easy. And remember, guys, it is not enough just to put the answer. I need a good explanation of why it is the right answer from what I just said. All right, what is the end behavior of the function? It's negative, so it's in the right order, right? That's our highest power. It is -2. It is x to the 4th. So that means x to the 4th means it's just like this previous one, where it's matching end behavior, right? And, y'all, it is a negative leading coefficient, so that means both ends go down. So -infinity, and +infinity, -infinity for our end behavior. All right, so that is going to be C there. So that both ends go down towards -infinity. All right, number 3, which could represent the function x to the third minus x squared plus 5x. So very similar to one we saw in the practice, but this time it's positive. So that means it's not a and it's not d. It's either b or c. So what's the difference between b and c? It's kind of subtle. B, it goes straight through. C, it bounces on 0, right? We want the one that goes straight through, because if it bounces on 0, right, that means x equals 0 is a factor twice, because it's multiplicity 2. But as we can see, guys, you could not pull x out of every term twice. You can only pull x out of every term once, because there's only 5x there. So that means it is going to be b. And our next question, guys, what is a characteristic of all cubic functions? A lot of people miss this one. A lot of people put they have at least 2 real solutions. No, right? They have at least 3 solutions, but guys, they only have to have 1 real solution, not necessarily 2. They could have 1 real and 2 imaginary. But what is definitely true is they have opposite end behavior, right? That's definitely true of all cubic functions. Like all odd functions, guys, they have opposite end behavior. All right, question 5. Which graphs could represent a polynomial function with 2 roots of even multiplicity, right? That means those 2 roots bounce. And 1 root of odd multiplicity, that means it crosses. All right, so does that have 2 roots bouncing? No, just 1. What about that one? No. That one has 2 roots bouncing, but it doesn't have another one. And that one, our last one here, has 2 roots bouncing and 1 that crosses. So it is going to be D. All right, next question. How many total extrema does the graph have? Pretty easy, guys. We're just counting the number of turns, peaks and valleys, right? So 1, 2, 3. So that's it. 3 total extrema. Another easy one there. Next question. The function models the number of cookies sold each day by a bakery during a 10-day period. Between which days did the number of cookies sold by the bakery decrease? All right, pretty easy. Just remember we read left to right. So between days 0 and 1, it's increasing. 4 and 5, it is decreasing, right? And then 6 and 7 and 8 and 9, guys, it's going up, right? 6 to 7 to 8 to 9, increasing. So our answer is B. All right, number 8. Which function is the same as 3?